Good morning. Welcome to Current SCHEM World. In this video, we will see how to obtain Van Hoff factor I value for association of benzoic acid and also dissociation of weak acids. Let us derive the I value expression for association and dissociation in this class. Okay, what is the Van Hoff factor I value for weak acid dissociation? Okay, I equal to 1 plus alpha. This is the I value for dissociation of weak acid, where alpha is the degree of dissociation. Okay, let us derive this. Okay, let us consider a weak acid which is partially dissociated to give H plus and A minus ion. Okay, at time t equal to 0, we have taken 1 mole of HA, weak acid. At initial time t equal to 0, H plus concentration is equal to 0 and A plus concentration is equal to 0. Okay. Okay, now at equilibrium, alpha, a fraction of weak acid is dissociated. Okay, alpha is the fraction of acid dissociated. Therefore, the fraction dissociated is formed. Okay, alpha is the dissociated number of fraction of moles dissociated. Therefore, this much is formed. 1 mole of HA gives 1 mole of H plus and 1 mole of A minus. Therefore, alpha 1 minus alpha. Okay. Now, total number of ions at equilibrium, total initial number of moles equal to 1. At equilibrium, total number of moles or total number of ions, moles of ions equal to 1 minus alpha plus alpha, that is 1 plus alpha. And what is the formula for I? I equal to total number of ions at time t divided by total number of ions before dissociation. Okay, therefore is equal to total number of moles of ions at time t equal to 1 plus alpha divided by 1. Therefore, I equal to 1 plus alpha, that is I equal to 1 plus alpha. Suppose you know I, if you know alpha, you can calculate I value. Okay, suppose you know alpha, then you can calculate, if you know alpha, you can calculate Van Hoff factor, or if you know alpha, I, we can calculate alpha, degree of dissociation. Okay, let us now derive the expression for Van Hoff factor I for association of benzoic acid. Okay, it undergoes dimerization. Okay, this is the I equal to 1 minus alpha by 2. Okay, how it is derived we will see now. For example, let us take benzoic acid as HA and HA n times. Okay, if it trimerizes, then n equal to 3. If it dimerizes, n equal to 2. Okay, now at time t equal to 0, similar to dissociation of weak acid, at time t equal to 0, let us take 1 mole of HA. Okay, and at t equal to 0, there is no HA dimer or trimer or polymer. Okay, 0. Now at equilibrium, that is a fraction is a fraction of HA is associated, similar to dissociated. A fraction of moles is associated. Therefore, 1 minus alpha divided by, okay, alpha by n. alpha by n. Okay, why? Because for 1 mole you get, for example, it is a dimer. Okay, you have 2, therefore alpha by 2. For n, alpha by n. Okay, now total number of moles of ions at equilibrium T equal to 1 minus alpha plus alpha by n. Okay, this is the general formula. Let us consider for benzoic acid association, it dimerizes. Okay, then n equal to 2. Let us substitute in the formula 1 plus alpha, 1 minus alpha plus alpha by 2 equal to 1 minus alpha by 2. Therefore, I equal to, how I, what is the formula for I? Total number of ions at equilibrium divided by total number of ions before association. Therefore, 1 minus alpha by 2 divided by 1, that is I equal to 1 minus alpha by 2. That is the value. So, these are very much useful for solving problems in various board exam as well as competitive exams. Thank you for watching. Please share and subscribe. Thank you again.